If you want to know where the AI revolution is heading next, I'm going to give you a piece of advice that sounds completely counterintuitive. Do not look at image generators, don't look at the latest video models, or the tools that can clone your voice in 3 seconds. If you want to understand the future of the internet, you need to look at watermarking. I know. Watermarking sounds like the most boring, corporate, bureaucratic topic on earth. It sounds like that faint, annoying logo you see on stock photos. But right now, the entire tech industry is quietly fighting a multi-billion-dollar war over this exact concept. Because we have officially crossed a terrifying threshold. For the entire history of human civilization, seeing was believing, a photograph was proof, a voice recording was evidence, a video was the ultimate truth. That era is over, it's gone, and it's never coming back. We are entering what experts call the post-authenticity era. A world where the human eye can no longer visually distinguish between what is real and what was dreamed up by a GPU server in Oregon. So, how do we fix it? Well, tech giants like Google came up with a solution. They built an invisible, digital tracking system designed to tag every single AI creation at the exact millisecond it's born. Google calls their version SynthID. It was marketed as the ultimate unbreakable shield against deepfakes. But recently, a group of independent researchers and hackers decided to attack it. And what they discovered exposes a massive, uncomfortable secret that the AI industry desperately hoped you wouldn't find out. Grab a coffee. Today, we're doing the deep dive into the hidden war for reality that nobody is explaining properly. To understand why SynthID is such a big deal, we first have to understand the lie we've all been told about digital tracking. Most people think AI watermarks are just metadata. You've probably heard this term thrown around by politicians and tech executives. Oh, we'll just require AI companies to attach metadata to their files. Think of metadata like a luggage tag on a suitcase. It tells you where the file came from, who made it, and when. It sounds great in a congressional hearing. The problem? Metadata is practically useless against anyone with a brain. If a malicious actor wants to spread a deepfake, they don't leave the luggage tag on. They just rip it off. You can destroy metadata instantly just by taking a screenshot of the image, or cropping it by 1 pixel, or compressing it to send on WhatsApp. Boom. The tag is gone, the image is clean, and the internet is fooled. Google knew this, so their AI division, DeepMind, built SynthID to do something entirely different. SynthID doesn't attach information to the media. It embeds the information into the media itself. It makes the watermark part of the DNA of the file. How? By using a mathematical concept called statistical steganography. Let's break down how this works across different types of AI, because it is genuinely genius engineering. For images, SynthID doesn't change the colors you see. Instead, it goes into what's called the frequency domain of the image. It makes tiny, microscopic, statistical adjustments to the pixels. To your eyes, it's just a picture of a cat. But to a computer algorithm, those pixels are vibrating at a very specific mathematical frequency. For audio, it hides a specific code inside the sound patterns, completely imperceptible to human ears, but perfectly legible to a scanner. For text, this is the wildest one. When an AI like Gemini writes a paragraph, it predicts text word by word, choosing from a list of probable next words. SynthID subtly manipulates those probabilities. It gently nudges the AI to choose specific words in a specific mathematical rhythm. It creates an invisible, linguistic fingerprint. Because this fingerprint is baked into the actual content, Google proudly announced that SynthID was incredibly resilient. It could survive being cropped. It could survive heavy compression. It could survive filters, resizing, and screenshots. They scaled it aggressively. Google embedded SynthID into billions of pieces of content across Gemini, their image generator Imagen, and their video model Veo. The dream was beautiful. A future where an AI company could scan any file on the internet and tell you with absolute certainty, yes, this is an AI creation, until the hackers walked in. Enter an independent developer and security researcher known online as Alosh Denny. Now, Alosh Denny didn't have access to Google's secret internal code. He didn't have a supercomputer, but he understood a fundamental law of physics and mathematics. Consistency is a vulnerability. If a watermarking system is going to work at scale, it has to be consistent. The algorithm has to apply the same type of mathematical fingerprint to every image it generates, and if something is consistent, it leaves a pattern. So, how do you isolate a pattern that's hidden inside a complex image? If you try to find a statistical watermark in a highly detailed image, say, a crowded city street, the visual data of the street acts like loud static. It hides the watermark. So Alashdeni did something brilliant. He went to Google's AI and forced it to generate images with almost zero visual information. Pure black frames. Pure white frames. Completely empty, minimal content outputs. Think about it like this. If you take a single piece of tracing paper with a faint invisible stamp on it, you can't see the stamp. But if you stack 100 pieces of that exact same tracing paper on top of each other and shine a bright light through them, the hidden pattern suddenly darkens and reveals itself. By generating hundreds of blank frames and using a mathematical technique called spectral analysis, the researcher isolated the watermark. He stripped away the noise and found the exact frequency fingerprint Google was using. And once you can see the fingerprint, you can figure out how to destroy it. This wasn't just a glitch in Google's matrix. This was a demonstration of a terrifying academic truth that the AI industry has been trying to sweep under the rug for years. In 2023, a group of elite computer science researchers published a paper with a title that reads like a death sentence for the safety industry. It was called "Invisible Image Watermarks Are Provably Removable Using Generative AI." Notice that word, provably. It's a mathematical certainty. The paper proved that if an attacker uses a second, separate AI model to slightly reprocess or regenerate an image, it completely scrambles the high-frequency pixel adjustments of the watermark, while keeping the image looking exactly the same to a human. It's called generative laundering, and it completely breaks the shield. Now, to be completely fair, Google pushed back on claims that SynthID was broken, and technically, they're right. A casual user can't just click a button and erase SynthID from every image perfectly across every resolution. Google's system is still highly advanced. But what the researchers proved is actually far more dangerous than just breaking a tool. They proved that the watermarking detector can be confused, and in the world of security, uncertainty is just as fatal as a total breach. Why? Because watermarking is fundamentally probabilistic, not absolute. When Google scans an image to see if it's theirs, SynthID doesn't give a binary answer. It doesn't say, "This image is 100% definitely AI generated." It says, "Based on the pixel frequencies, there is a 94.2% statistical probability that this matches our watermark." But remember what happens to a file when it travels across the internet. It gets compressed by Twitter. It gets upscaled by a blog. It gets re-encoded by Facebook. It gets cropped by a user. Every single one of those completely normal actions adds digital noise to the file. Every time noise is added, that detection confidence collapses. If an attacker intentionally injects just a tiny bit of mathematical interference based on the hacks we just talked about, that 94% confidence drops to 50%, and a 50% confidence rate is useless. If a platform can't be sure, they can't flag it. If they can't flag it, the entire system of trust breaks down. This brings us to the uncomfortable secret of the tech world. Watermarking is not a lock on a door, it is an arms race. It is exactly like email spam filters. Think about it. Why do you still get spam in your inbox in 2026? Tech companies have spent billions fighting spam for 30 years. They have the best AI in the world filtering your emails. But spam still gets through, because the moment Gmail builds a better filter, the spammers build a more clever email. There is no such thing as a perfect, permanent watermark. There is only a temporarily difficult watermark. But let's step back and look at the biggest, most brutal flaw in this entire grand plan to save reality. Let's pretend for a moment that Google, OpenAI, and Microsoft somehow invent a flawless, 100% unbreakable, invisible watermark tomorrow. It still wouldn't save us. Because of the open source loophole. Systems like SynthID only work if the software creating the media cooperates. Google controls Gemini, so Google can force Gemini to stamp every image. OpenAI controls DALL-E, so they can force it to stamp every image. But the fastest growing sector of AI isn't corporate. It's open source. Right now, anyone with a decent gaming computer can download incredibly powerful image and video generation models directly onto their local hard drive. These models are completely decentralized. They run offline. They don't report back to a corporate headquarters. If a malicious actor wants to create a devastating political deepfake to disrupt an election, or ruin someone's reputation, they aren't going to log into Google Gemini and ask it politely to make the image. They are going to use an open source model running locally on their own hardware. And do you think an open source model modified by an anonymous developer on the internet is going to voluntarily inject an invisible tracking watermark into its pixels? Of course not. So, the cruel irony is this: the only people whose content will be watermarked and tracked are the honest everyday users creating harmless internet memes. The people actively trying to weaponize deception will simply use tools that don't have walls built into them. So, where does this leave us? If watermarking is just a temporary speed bump in an endless arms race, does that mean we've completely lost the war for truth? Not necessarily, but it means we have to stop looking for a single magic bullet. Right now, the tech industry realizes that a hidden pixel pattern like SynthID isn't enough. They are scrambling to build a multi-layered defense system. In the future, verifying a piece of media won't just be about checking one invisible stamp. It will look like a castle defense system. We'll have cryptographic metadata signatures, systems like C2PA that act like a digital birth certificate signed by the actual camera that took the photo. We'll have hardware-backed capture pipelines built directly into your iPhone or Android processor, proving the lens actually saw real light photons. And we'll have invisible watermarks like SynthID acting as a fallback tripwire. But even with all of that infrastructure, the fundamental relationship between humans and the internet has fundamentally changed. We are entering an era where reality itself is no longer auditable by the naked eye. Trust is no longer going to be baked into the content you consume. Trust is going to become platform dependent. You will trust a video not because of what it looks like, but because of the verified, secure chain of custody of the website displaying it. Watermarking systems like SynthID are not the final victory. They are just the first defensive wall in a war that will last for the rest of our digital lives. The internet used to be a mirror of our world. Moving forward, it's a hall of mirrors, and we all need to start learning how to navigate it. Thanks for watching. If this deep dive made you look at the internet a little differently, hit that subscribe button, leave a comment with your thoughts on how we solve the deepfake crisis, and I'll see you in the next one.